recording everything.
No, that's good.
So.
Okay, I'll start reading and then
okay.
we'll just take turns. So question 3. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? It would also be right skewed. Right? Because
yeah, it's right. Wait, hold on.
Because the sample size is too small.
It should still be skewed right. Right?
So the next one, yeah. So then in 4, if the sample size is 100, then it would be normal.
Right. Because it's a big enough sample.
Right. Okay. Okay, number 5.
Normal.
It's normal again?
Right.
Yeah, if the parent population is normal, then it's normal.
Right.
Okay.
So
it would also be, that's normal again, right? Isn't 6 normal too?
Yeah, it's got to be.
Yeah. Is this too easy?
It's. I think it's right.
Well, we get 2 tries.
I know. All right. Whose turn is it to read?
I can read.
Okay.
When would the distribution of means be normally distributed? Choose all correct responses.
Okay. So
is it the normally distributed and the sample size is large?
wait.
Well, the first one, yes. Do we all have them all in the same order?
Okay, so data from a population that is normally distributed and the sample size is small is correct.
Yes, because if the parent population is normal, then the sample mean is normal. So that one's good.
Yeah.
Data are drawn from a population that is normally distributed and the sample size is large. That's also correct.
Same thing.
The sample is large. The data are drawn from a population that is right skewed and the sample is small. No. And data are drawn from a population that is right skewed and the sample size is large. Should be normal, right?
Right. So 3 out of the 4.
Yeah.
Okay.
Okay. Which of the following gives the best explanation of the central limit theorem? Well, it's not the 68, 95, 99.7 rule.
Oh, are you sure?
Darn. Okay. If the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution. No. No. If this is large, then the sample mean would be close to the population mean. Nope, that's law of large numbers. If the sample size is large, the shape of the distribution of sample will be approximately normal. That's the one. At least that's the one that is almost exactly worded like my notes. So that's what I'm going with.
Okay.
Do we all agree?
Yes.
Yeah.
Oh, Balderdash.
Okay, now we got to calculate some stuff.
Uh-huh.
Hang on, I'm trying to write them all down just in case we have to go back at all.
That's
Sorry. Okay, I'm caught up.
So the mean is just the same, isn't it?
Yeah, it doesn't
The mean. So it's 10 in number 9.
That's
number what?
What is the mean of the distribution of sample mean?
Let X be a random variable with the population mean.
That's
so
why
yeah,
I'm
10 is the same. It's the
It
same.
doesn't change.
Yeah.
The population is the same as the sample. Is the standard deviation of the sample? Well, that math, shall we?
So,
Is the standard deviation the same too, or is that a different one?
No, that's the problem where it's the
you
population
divide it.
deviation divided by the square root of the number.
I got 1.
Hold on, I'm not that fast. I had to find my calculator.
Because the square root of 36 is 6.
Yep. That's it. 1. I got 1. Okay.
All right. So are we on to the next one?
Yeah,
Yes.
number 11.
Okay. Regardless of the distribution of the population, if the sample size is large, n is greater than 30, what would be the shape distribution of the sample mean? I feel like I said the same 3 words like 5 times.
What would be normal?
Normal. Let's just say normal for like everything, okay?
Mhm.
Apparently that's the magic answer to me.
That is.
What theorem would justify your response to the last question?
What's the central limit theorem?
Yeah.
Because that's the one about the shape, and the law of large numbers is the one about the spread.
Yep.
Okay.
Okay. We ready?
Sounds good. Yep.
All right. I hope normal is a good answer.
I know. We sure use that a lot.
I know. All right. Normal is the magic answer. Look at that.
Woohoo!
Here we go.
We did it.
Nice.
All right.
Okay.
That
Have you
was
guys started
too
on
fast.
lesson 7 yet?
What?
No.
You haven't started. It's more complex.
Sweet.
Don't say that.
I love
It
that.
is. Well, I had to
No,
keep,
they're all supposed to be simple.
I had to keep going back to
So-
lessons 5 and 6, like a lot.
Okay.
So take notes of all of those, like just before you start lesson 7, just go back and write down all of the equations, because we're gonna need all of them it's starting to combine everything now.
I feel like there should be something that already has them combined on a paper and we just click on it and it just pulls
Yeah,
it up.
yeah. And it's a lot of using that little applet thing again. So
Ugh.
I'm kind of like halfway through the homework assignment right now, and my mind is it's like
You're
For
so
real.
real.
yeah, my brain is tired thinking about it. So yes, good luck, and let's talk again on Wednesday.
All right. Sounds good.
All right.
Okay.
See you later.
Thank you.